Thank you, Taylor. Welcome everybody. I'm Jonathan Blocksom. This is our session at the DevCommunity Summit on LiDAR on the iPad and the iPhone. The LiDAR in your pocket, I believe it was titled in the conference. I did a search recently. I found somebody else had also used that title for an article, so I was a little disappointed it wasn't as original as I hoped. Anyway, and it's got to clear up. Got it. Okay. Let's see. So, just give me a second to orient myself. I haven't done one of these in a few months. So anyway, I'm Jonathan Blocksom. I work for a well-known financial company. I did not go through my employer's speaker permission form to give this talk. It's more of a personal thing. So I can't tell you where I actually work. I'm actually not allowed to say that. But it's pretty obvious if you search me on anything. Anyway, thank you for coming to the session. Today we're going to talk about the LiDAR sensors that were added to the iPad and the iPhone in the last year. It's pretty cool capability. I have a history with LiDAR. Some of my background is doing defense work and mapping work using LiDAR sensors, using GPS, all sorts of different technologies, fusing them all together to make maps. And so when Apple announced that they were putting LiDAR on the iPad back in the spring of 2020, I was pretty excited. In fact, it was probably the most exciting thing about the spring of 2020 for me. Anyway, so I rushed out and I bought one of those iPads. Have it here, and sure enough, it had a LiDAR sensor on it. So I started playing with it, and my goal today. My goal today is to hopefully you can all see the screen share. Can someone give me someone say they can see the screen share?
Yep, we can see it.
Okay, thank you. All right, some thumbs up. So our goal here today is just talk a little bit about what LiDAR is, give you folks, just working knowledge, good enough for a cocktail party about what LiDAR is and why it might be on these devices and where it came from, that sort of thing. We'll talk about how it's used on iOS, show some cool pictures, I think, of it actually in use. We'll talk a little bit about how to program with it, not very much. I know it's Friday afternoon after 4:30, so the last thing we want to do is go into XCode. Second to last thing, really. But then we'll look a little bit about how you code with it. It's actually very simple. Have some Q&A, and then anyone who wants to stick around, we might mess around with trying to visualize some things, trying to see what it does with my setup. I was hoping to have a very demo-heavy session, but with the limitations of Zoom and trying to run something on the device that doesn't run in the simulator, it's been a little bit prohibitive for demos. So we're going to keep it to some simple videos, but then we might try some stuff at the end if anyone wants to do that. So that's our agenda for today. So without further ado, let's start to dig in to what is LiDAR? LiDAR, it's similar to radar. LiDAR is light detection and ranging. Radar is radio detection and ranging. It's actually light detection, I believe. Actually, I'm questioning myself now. Is it laser detection and ranging? But no, it's light because it's LI. Anyway, you know how the laser is an acronym for light amplification by stimulated emission of radiation, which I know because it was in my 3-year-old's book about construction equipment. Anyway, LiDAR uses lasers to do depth sensing. It's similar. There's a similar thing called structured light, which I'll mention a bit later. But the way it works is you have a laser, and you shoot out a laser pulse, just a little tiny pulse. Not a continuous one, and you start your stopwatch when you shoot out this pulse. Now we're not talking about a person; we're talking about fancy electronics. So it can be a very high precision stopwatch. But at the end of the day, it's a timer. So you shoot out a laser pulse from a laser. And then that laser is going to go out into the world and it's going to hit something. And when it hits something, it's going to bounce off it. If it's an object that is not like a shiny mirror, it's probably going to bounce right back to where it came from. And then that pulse is going to come back to a receiver that you have in the sensor. And the receiver usually is tuned to that wavelength. It's got a little notch filter, so only the wavelength of that laser comes in. And that's when you stop the stopwatch. And so if you started it when you sent it out and you stopped it when it came back, which, speed of light is pretty fast. So it's got to be pretty fast electronics. Then you can just divide by the speed of light and you can find out how far away something was from the sensor. So this is all pretty neat. And what this is called is time of flight. So the LiDAR that is in the iPhone is a time of flight sensor. And so the chipset that's in there is sending out this light and then measuring how long it takes to get back to it, and then turning that into a distance and doing a whole bunch of processing to turn that into a depth map that you can use in your software. Now, for purposes of illustration in this slideshow, I only showed one sensor, but what usually happens is you have either a bunch of them in a line, and then that line sweeps around to get the scene, or actually in the case of the iPhone, it's on a grid pattern, which we'll see, and it shoots it out all at once and it comes back. Sometimes you hear of this called flash LiDAR, where it shoots out a bunch of pulses at once and they all come back at the same time. So that's generally how it looks. And when you combine all these things together, when you combine all of these measurements for distances from the sensor together, you get what's called a point cloud. So point clouds are big in the LiDAR world. It's basically just your simplest way to visualize something that we have. It's just you take every distance and you figure out where the sensor was and you put it that far away from the sensor and you draw it, and then you can visualize whatever you just scanned. This particular point cloud is from a Radiohead video, which I'll talk about in a few minutes. Let me pause there. Any questions about like the technology behind LiDAR so far? Nope. Okay. I've got the chat window up on the side here, so if you do have questions, just drop them in the chat. Pradeep, I'm glad you liked my joke. So we create these point clouds with LiDAR, and that's kind of the basics of the technology. It's been around actually since the 70s. Now, if you think about technology back then, lasers were pretty expensive, pretty big. It's not the sort of thing that could fit in your pocket by any means. And GPS and stuff wasn't really there either. So, but they were using it to start studying the atmosphere. So, and the idea of using light to measure things is a very old idea. So, but it was really, the 70s they started messing with it. In the 90s, it was really with the advent of GPS. That's when you started to be able to make maps with it. And one of the interesting things about LiDAR is that by itself, as a technology, it's not that useful. Where it really gets to be useful is when you start tying it together with GPS or some sort of location measurement. In the iPhone, you've got the accelerometer and math to do inertial navigation to just figure out where your phone is in the room, where it is in your hand, and where it's moving from frame to frame. When you start tying all that together with the depth measurements, that's when you get the really interesting things like point clouds that are geolocated. So you can start making maps. So you could start scanning rooms, scanning objects, and doing all of that sort of thing. So really, one of the things that I'd like you to remember about this is that the LiDAR sensor is pretty cool, but it's really the LiDAR combined with the accelerometers and the cameras and all of the processing in the iPhone that makes it useful. LiDAR by itself just gives you a bunch of depths, and it's really turning it into something useful that takes other sensors. So in the 90s, when GPS was unlocked for civilian applications in the 90s, that's when companies were able to start making maps with it, or it was still very expensive, so it wasn't the sort of thing you'd go and do on your own, but you could have a GPS measurement on something and start making maps with it. Usually that was done with airplanes, which we'll talk about in a minute, and then later on that was brought down to the street level, and LiDAR became one of the things that empowered or that really powered Street View and other street level mapping efforts by Apple, by Google, by I forget it, the one that begins with a T, but all the different companies that were making maps. And then most recently, it's come down to the handhelds. So if you look at LiDAR technology, you've got this fascinating thing where LiDAR sensors used to be hundreds of thousands of dollars or millions of dollars, and nowadays I don't know how much the chip in the iPhone costs, but if your iPhone is only a few $100s, then it's got to be on the order of dollars. But the number of them in use, back when they were $100,000, you'd have a few dozen in the world or something like that. Now everyone who has an iPad Pro, an iPhone 12 or iPhone 13 Pro Max, they all have LiDAR sensors. So you've got millions of LiDARs just out there shooting lasers all over the place. It's a dangerous world. It's actually not dangerous. These are eye safe. That's actually one of the big things. The aerial ones, you probably wouldn't wanted to stare into one that was on an airplane up close. But the ones that were used on vehicles were generally eye safe. Again, you wouldn't want to stare at it, but if it flashed by you, that would be okay. The ones in your phones are definitely low power enough to be eye safe. Check in for questions. If you have one, drop it in the chat. So I just think that's pretty cool that we're seeing this LiDAR usage. We're seeing this sort of thing that you see with Moore's law, where the quantity of sensors is going off the charts, the cost of them is coming down, and that just means we'll see more and more applications, and the technology will get better and better for it in the coming decades. It's helpful though, like I wrote it down. I don't know how many of you caught Julie Eberfield's talk that kicked off the conference, the keynote, which I really enjoyed. But I liked, it is only in looking backward that we can see how far we've come. Now, of course, she was talking about diversity. I'm talking about LiDAR, very different things. But I liked that backward-looking idea that looking at where the LiDAR technology has been, we can see kind of where it might go, and we can see how far it has come. And so, just to give you a little bit more history of LiDAR, one of the first big applications for it was mapping, and in particular, putting this big sensor, because this would be a sensor, a few feet by a few feet by a few feet, just for the casing and everything. And it would have a powerful laser. It would need a large power source. And you would fly your plane around. Your plane would have a GPS on it. You would also have a GPS on the ground that was stationary. And your plane would also have an IMU, an inertial navigation recorder, and an inertial sensor that recorded just yaw, pitch, and roll, accelerometer, that kind of thing. So you would record as much of this velocity and acceleration data as possible, as much position data as possible, and then position data from a ground station. And then you would shoot your laser out at the ground while you flew over the area. And when you did that, you'd get a bunch of stripes. Now, it took an awful lot of processing. The reason you had something on the ground recording your GPS, and then something, and then the GPS on the airplane, and not just the GPS on the airplane, is because to really get down to sort of the sub-meter accuracy that you would want for a map, you needed to compare the GPS on the ground that you knew was stationary with the GPS in the airplane. And there's a thing called a Kalman filter. It's a mathematical operation. It kind of looks at the whole trajectory going forward and looks at it going backwards and does a whole bunch of math to smooth it out really, and to take errors that might have happened in the airplane, correlate them with errors that wouldn't have happened on the ground, and get a better solution. And so you would take these sources of data, fuse them together, and then you were able to get a map of the area, an aerial map. And a lot of these maps are actually available out there in public. They are, when you look at Google Earth or something like that, they're leveraging all of those data sources that are out there that are done by the USGS or different states and municipalities to record these things. There's also lots of other applications for aerial LiDAR. It's big in ecology, using it to like measure forests, or agriculture as well, using it to measure crop yields and things like that. So there's a lot of different applications for aerial LiDAR. That was kind of the first big place for LiDAR. And then in sort of the 2000s, LiDAR sensors shrunk enough. Hang on a sec. LiDAR, sorry, my son just walked in from school. LiDAR sensors shrunk enough so that you could actually put them on something like a car. So they were kind of the size of a coffee machine. In fact, we used to call these Mr. Coffee, like the Mr. LiDAR thing. Hang on a sec. Yeah, you can just walk through there on the side, son.
The lights its field of view.
Oh, it can't see you. Don't worry.
Good.
But you're very handsome. I did tell my kids that I would be giving a presentation from 4:30 to 5:30, and to be careful when they came in. So anyway, I co-opted the living room for this. So okay, so LiDAR sensors have shrunk. It's 2005. They're the size of a coffee machine, and so we start putting them on cars. Plus, everything's getting cheaper. These two sensors that I'm showing you here probably cost around $10,000 each, as opposed to say $100,000 each. Could be even cheaper because I think this one is from more like 2015. On the left there, we have a Google Street View car where they just put a whole ton of cameras and LiDAR sensors and everything on it. They sort of said, hey, we don't really know how we're going to get the best maps. So we're just going to take as much data as possible as we drive around, and we'll figure it out once we get back to our office. And as the mapping world has sort of streamlined things, they figured out, oh, okay, these are the kind of sensors we want. You actually see that little disc up front. Oh no, that's probably just a smaller LiDAR, but you'll have some inertial navigation systems on there as well to just track the acceleration of the vehicle and its turning and all that, tilt. And this all gets fused together. So you put these LiDAR sensors on your car, you drive around, you usually have another one of those stationary base stations with the GPS. You do a whole bunch of processing, and then you're able to get street level LiDAR, which is sort of the thing that powers the things like Street View. I'll give you a little example of this, and we're going to play a little video. So in 2007, I believe, Radiohead, the band, they came out with a video for their song House of Cards that was all based on LiDAR. There's no sound. Welcome to the House of Cards. Da, 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 da. I don't really know the song that well. It's very mellow. But this little video that I've just played for you has some street level LiDAR here that you can see. It's got the point cloud, and then they've added that's the person's face. I'll skip the face, but hopefully you can see me scrubbing this video. I'm not too sure it's working, but you can see that this little effect here, they've kind of blown the points away, and they're doing that algorithmically. So they've just written some code to go in, and as the camera rendering the scene goes through, it just moves the points away. I think one of the interesting things about this is that you can see that the car that drove around, you can see how tall the buildings are on the sides and the height. And that was, certainly your field of view was one of your considerations when developing a system like this. Now, this picture, this picture on the left, that's the actual sensor that they used. It's a Velodyne LiDAR sensor. The way this one works is it shoots a line and then it spins around really fast. And so they actually drive into a cul-de-sac, and you get sort of a view of all the houses in the video, and you can kind of see that you can see the size of it, and they put it up so that it gets as many points as possible that without being occluded by the roof of the car. There's links to the video on YouTube and a video about the making of it down here. So, feel free on your own to go check those out. I will say also, the beginning of this, the beginning of this video with the fellow's face, and I showed that face earlier, that's not actually LiDAR that they used for that. That was something very, very similar called structured light. Structured light doesn't work by time of flight. Structured light, which is the same technology that was used in the Kinect sensor, the original Kinect sensor. Time of flight works by structured light works by shooting out a light pattern and then visualizing that light pattern from the side and doing triangulation to determine where the points are. So it's a different approach than LiDAR. It's not using time of flight, it's using triangulation and geometry to figure out where the distances are. One of the interesting things about this video, or sort of a personal note, in the making of this video, they talk about how they were messing around with these sensors, and they were trying all these things, and they were having the singer sing while the sensor was recording the data of his face. And then they started taking like sheets of plastic and things like that and putting it in front of the sensor and warping it to get weird different effects. And I thought it was kind of funny because as a sensor person and as sort of a data lineage, a fan of data lineage, it wasn't really called that at the time, but someone who's like collects the data and then process the data, it really bothered me that they were like obscuring the sensor data and they didn't just do it in code. I was like, you could just go write a little script to mess around with all the points. You don't need to mess around with that at the sensor. Then you'll never get that data back. It's like it's gone. Oh, thank you, Eric, for saying scrubbing was working, by the way. Anyway, Radiohead 2007, check it out. That was state of the art at the time. And now, 13 years later, I mean, there was a lot of progress in that time. Flash LiDAR was actually, I remember seeing a flash LiDAR sensor back in like the 2009 period, and didn't really work that well. It was pretty low density and it wasn't very far. But again, we weren't looking at inside the house applications. We were looking at applications that were like on vehicles and stuff like that for the work I was doing. Well, okay, iOS and the iPad Pro comes out in spring of 2020, and it's got LiDAR on it. And so, this is now here. They built it into the SDKs. It's in the ARKit SDK is what you use to start programming with it. And it's also just in apps you might be using all the time. If you're using the camera app, and you're going into portrait mode, it's using the LiDAR to figure out the depth to know where to focus, how to change the focus for different things, to pull out the background, to do the computational photography effects on the background. So the LiDAR is there in practice. If you're using Measure, which by the way, it's a great app. Like I tend to forget that I have it, but I don't know if you don't realize it's on your phone, give it a try, but you can just measure stuff in your house or wherever you are with it. I've found many times where I've been like, oh, I wish I knew how long this was. And Measure is right there on my phone and it works. Anyway, that's another app that uses the LiDAR sensor. And there's a whole bunch of other photography types things that mess with it. So, and then there's the more obvious applications like scanning apps that third parties have written and all that use it. Furniture apps like Wayfair. If you're buying something from Wayfair or perhaps IKEA, and I know Wayfair has the button view this in my room, and you push that, and then you hold your iPad up, and you can view it in your room, and that works fine. And that's all powered. That's all powered with ARKit and the LiDAR sensor. Give me. Okay, head it out. Yeah. Catch you later. All right. Pause for any questions. Okay, what we're going to do now. I did some messing around with trying to visualize what actually happens with the sensor in your phone, and this is actually one of the main reasons I wanted to give this talk. Is I'd been meaning to do this for a long time, but sometimes you need a little kick in the pants. So I set things up so that I had an old camera that had a night shot mode and a night view mode. I taped over the infrared light on it, but it still was recording infrared video. And I plugged that into a monitor so I could see the video. This was kind of an old camera. I'm not able to hook it up to this, otherwise I'd show it to you live, but this is like a camera from 2002 or something like that. Anyway, I put a few things on the table. I ran an app on the iPad that would turn on the LiDAR sensor, and then I used the camera to visualize it. And so this is kind of this is just some images that came out of it. What you can see in the infrared view is you can see the pattern of dots that comes out from the sensor. And so this was pretty cool to me, and you can see it shining on the blocks, and as you move the sensor around, you could see them. And I'll show you. Well, I'll just show you in video on the next thing. So here's a little video of that actually happening. The video is in slow motion, and what you'll see is, sort of a little shimmery pattern. I'm not totally sure if that's the sensor or if that is the video tied to taking the video. The camera I'm using to take the video combined with the display. So I don't quite know for sure, but I think it might be the sensor. So if you were like the predator alien come to Earth to, I don't know, have some sport, and your prey got out their iPhone and wanted to take a picture of you, that might be what you see in your infrared view, because as we all recall, the predator could see in infrared. Also, it bled, so we could kill it. Anyway, that's the infrared view of the iPhone, measuring a scene, and we'll just let that go another second. There we go. Oh, there you see it shimmering a tiny bit. So let's now talk about how we want to use this in our software. So the cool thing is Apple does all the heavy lifting for us. The downside of it is we don't actually get the raw data. Apple has already written all the code to take the LiDAR data, fuse it into a 3D model of the scene, or a depth map, either a depth map or the full 3D model, and let us use it in our code. So this is all done inside of ARKit. Now there's actually no way to get the raw LiDAR data. It's not exposed as a camera like the other cameras are on the device. So, and whether that's going to change or not, it's hard to say. It's kind of an interesting thing. There's some pros and cons to that. Oh, here we go. Sorry, I'm kind of jumping ahead a bit. I'll jump back. But yeah, there's some pros and cons to what Apple's decided to do in terms of giving us access to the data or really not giving us access to the data. So in the WWDC session talking about this from 2020, they use the phrase like advanced machine learning algorithms, which fuse this with camera data to give us a depth map. It's great because we don't have to know the algorithms to code it. So we don't have to be experts on like SLAM, which is software localized mapping, or or any of these fancy computer vision things that are used to build a 3D model from this data. All we have to do is turn on ARKit and say, hey, we want some depth data, and then we're able to get it and use it. And if all we want to do with augmented reality, if we want to do something like one of those furniture apps where we just want to put some 3D shapes inside our scene or something like that, we don't even need to worry about the LiDAR. We just say, yeah, go ahead and start up an AR session and put some depth, give us the depth buffer, and it'll go ahead and turn on the LiDAR for us. So that's great. It may be frustrating if you wanted to have access to that raw data. Maybe you're making a scanning app and you actually have your own more advanced machine learning algorithms, or maybe you want to develop advanced machine learning algorithms and you want access to that raw data. We don't get that with the sensor as it is. Okay. So we don't get direct access to the LiDAR return data, but we do get this depth map that's processed, and we get a confidence value with it. And so that's pretty cool. And all you have to do to use it, and I've got this code on the right is from Apple's sample point cloud. I believe that's what it's called. It's in the bibliography at the end. It's from the sample point cloud sample code. And all we have to do is when we initialize our ARKit session, we'd say, hey, go ahead and in the tracking configuration, and the tracking configuration is how we're telling ARKit, hey, this is how I want you to keep track of the user's device. This is how I want you to, these are the parameters for what to do. And we say, hey, make sure that you're getting the scene depth. And in this case, we want the smooth scene depth as well. And then we just start up the ARKit session. So this is the code from that thing. Now, there's a lot more to it. Any AR stuff you're going to do, ARKit's actually fairly easy. It's fairly easy if you're using it with SceneKit, but there's a lot of boilerplate code involved. So we're not going to go into that today, but I just want you to know it's out there. But the actual part that turns on the LiDAR is right in here. Now, there's three different things you get from the LiDAR data. So you get the scene depth. The scene depth is frame to frame. What are the points? Not necessarily coming out of the LiDAR because it's fusing everything for us, but what is the most up to the most current view of what the depth is away from the user's sensor, from the camera chassis of the device. Next, there's one called smoothed scene depth. Smoothed scene depth. I think it's wrong on the second bullet there. The smoothed scene depth is an average over a number of frames of the depth. And so if you have something moving through your frame, or if you have like maybe a ceiling fan or something like that that isn't going to be constant, this will let that go away and then get the say the ceiling behind the fan. So that's a very handy thing. And then on top of that, there's also a confidence map. So if you know that you're in a place where there's not going to be many points that you're interested in, or that you want, like you're mostly interested in the wall behind a bunch of things, you can say, okay, just give me the really high confident points and filter out all the rest. So those are some things you can get with the confidence buffers. We talked about this a little bit before about how the sensor data is fused for you. The other thing that's there is that if you want to actually draw some of this stuff, you're going to be writing some shaders, and those are going to be a pain because they're kind of always a pain. They can be fun, but really the pain of it is you're going to be doing some transformation matrices. You're going to be doing, figuring out your camera position, using that to turn the depth map into a point in the world. And it's just, math, and it's not the math that's the pain. It's just that it takes some debugging time and all that. The other thing that's kind of a pain is this doesn't work with the simulator. Those of you who may have been programming with cameras and stuff for a while are probably used to this, that it's going to take a while for the simulator to catch up, if it ever does, with this sort of thing. We're going to switch over to XCode for just a minute, and I want to point out a few things in the code. If you have a question, now's a good time to drop it into the chat, because we've got about 4 minutes left, I think, on our clock. I will hang out after the session to do this. Let's see. So I'm going to stop that share, and then I'm going to share XCode. Okay, and now I'm going to try and find the chat window again. There it is. Okay. So the thing I wanted to share in here, well, there's the, this is the code that we looked at before. I'll leave that unhighlighted. The other thing that's interesting here is that you need to check to make sure, if you want to use the LiDAR, you need to check that your device supports it. So in this case, there's a little guard clause here in the startup of the AR session code to say, hey, if you don't have depth or the smooth depth, then don't do this. In a real world app, not a sample app, you'd want a little more robust handling, but for the purposes of this demo, it works fine. But yeah, here's all you do is create this tracking configuration and add in the depth and the smooth scene depth. The other thing I wanted to look at was the shader, and shader code is always fun to look at. Let me hide this. There we go. One of the interesting things, you saw, if you think about the picture that you saw a few minutes ago with the confidence map, and it had the different colors. Here they've got a little shader that does that for you. The code is lengthy, but it's a pretty simple thing. It's figure out, it's just doing some math. Then, I talked about doing the projection matrices stuff. So in here, you're sending in camera intrinsics. So your camera intrinsics is, where is the camera? What is the field of view? What is the focal length? That sort of thing. Those are the intrinsics of the camera. You use that to calculate the vertex's real world coordinates. So this is where you're saying, okay, the LiDAR gave us depth. We have to figure out from the camera, we have to go from the camera to that point in the world. So we're using the depth to go from the camera point of view to this spot in the world. So we're, you're doing all that math to figure out how many pixels are there in the depth map. So what's the horizontal position and the vertical position, and then put it out. So, great thing is Apple's provided us a sample. We can use that to get a running start on this code. But yeah, if you want to start visualizing point clouds, you're going to be doing math like this in your shaders. It's possible if you're using SceneKit, you won't have to do this sort of thing. SceneKit is a much more higher level API. I haven't messed much with ARKit and SceneKit yet, so I'm not too familiar with what its capabilities are. I think that's what I wanted to show you on that. Double check. Yeah, mostly the coloring and then some matrix math and all that. I don't know if we, let's try and run this. Oh, it's already run. I don't know if this will work at all. I've got like XCode, and I've got my iPad, and I've got Zoom. Can you see that? Can anyone, does it have me there in a point cloud? Is it visible at all? I can't see video of you folks.
It's in and out. It's hard to see. Oh, now we can see it. It's hard to see
Wow.
with the virtual background.
Let me try and turn that off for a second. I think, can I do that? Zoom. I'm going to stop the share and then restart it. So I had to stop the share to get my. Okay. And then I'll start the share again with XCode. But I don't know if you can, I can barely see what it's showing, so I don't even know. Taylor, are you seeing anything?
We can see something. It's definitely hard to make out.
Yeah, well, and that's why I sort of eschewed the videos. You see sort of down in the, oh, here's the actual, oh, hey, oh, I can like see my reflection on the TV. This is the depth map that's been colored with a color scheme, and I have no idea if that's coming through or not, but what the heck. I do encourage you, if you have a device that works, download this demo. I've got a link to it, and try it for yourself, and it should be kind of fun. Let me just jump back to the slides real fast. We're basically finishing up, so it's time for Q&A. Yeah, what questions do you all have, if any? I've got the chat back up now, so you can drop questions in there. In the bibliography that I'm showing here, this 2020 session, there's about 10 minutes on it right here, 10 minutes on it in that session, and it's a very good overview of just what you can do with it, how the technology works. They've got a fun animation about the time of flight, and it's just a nice little well done clip. And then the sample that I just showed is linked to here. What drove my attention to LiDAR? Oh, well, so I had a job where I worked on it, as I talked about, doing the terrestrial LiDAR stuff. So I worked on some DARPA projects where we put LiDAR sensors on vans and drove around town and made maps and things like that. So I was just always, I was exposed to the technology. I have a background in 3D graphics programming, so the graphics stuff was a natural fit, I could just pay attention to kind of virtual reality and augmented reality applications and where they're going. I just think it's an interesting area. I don't do a lot of that professionally and in my job at a financial company, but it is just a fun area I like to mess around. What do I see as primary use cases for iPhone LiDAR? Good question, Dan. So I think it's pretty obvious that Apple is headed towards augmented reality stuff. Be that glasses or a virtual reality type enclosure or something like that. Apple has a way of building technology years before its time. For example, you look at blocks in Objective-C, and those blocks came out in like 2010 or something like that, but really they were useful in Swift, and when Swift came out, it was like, oh, this is such a natural fit for this language. So, and you see that with other pieces of technology too, how they build the groundwork for things way before they need it. So I just sort of expect that Apple is working on augmented reality type stuff. Who knows if it'll ever make its market or not? I mean, it may not, but they're building that technology into the phone, into the iPad. It does have some cool use cases for things like 3D scanning or like looking at measuring things. So yeah, that's kind of what I see it. I see it as just sort of another sensor that they're building in, and the applications, like, you know, I don't think we would have thought of Uber if we had thought about the applications for GPS. You know, we might have thought about turn-by-turn navigation, but we might not have thought that, hey, that's something that can actually power someone in a car, meaning someone who's not in a car. So that's where I think the interesting thing will be, is the applications we don't know yet. But yeah, I do think it's all sort of in this augmented reality type stuff. I do consider like the Measure app, and I see there's a question, can we use it to measure heights? So yes, I mean, you know, the LiDAR itself projects out from the phone, but then you use the knowledge of where the phone is to turn that into a full 3D understanding of your scene. So yeah, if you fire up the Measure app, you can actually, you know, you could scan it. You can measure vertically, horizontally, far away. Just it's, you know, it's in space, right? Space like your local space. Good. I also think it's fascinating that it's really cheap now, because that's just, you know, that's a huge enabler for technology. You know, it's the sort of thing that you'll start seeing it in a lot of other devices that aren't iPhones. You know, you might start seeing it in like Ring cameras at your doorbell or something like that. Alexas, who knows? One of the interesting use cases, by the way, that I was reading about as I prepared for this talk, a company that was working with this talked about using it for estimating the volume of stock at a warehouse. So, you know, if you knew the size of, you know, a single unit, you could estimate how many units of this. This is something like I was imagining, you know, a not regularly shaped box type thing, but say, you know, say a bunch of forks or something in a giant bin. And how many forks do you have? Well, you might be able to use that to figure out the contours of the pile, and then do some math to figure out how many things there are in there. I think another interesting application that I saw, oh, it just escaped me. I can't remember. I was thinking about it though. I don't know, maybe I'll remember it, maybe not. How accurate is LiDAR? Great question. How accurate is LiDAR scanning? So the LiDAR on your phone is probably accurate to a centimeter or two. It's not down to the millimeter level, but yeah, a centimeter or two. Oh, and that reminds me of what the other application I saw is a company, you could imagine it using it for something like measuring the wear on your tires. Or, you know, I once worked with a construction equipment manufacturer to develop some computer vision algorithms to measure wear on the treads of bulldozers. And that was fascinating because, I mean, they were interested in being able to measure it so that they could sell more treads, which apparently that's a big deal to bulldozer owners, but to sell more treads to the bulldozers, and specifically to sell them from the company and not from a third-party manufacturer. So, you know, you could think of taking your iPhone out, you know, if you're a construction worker, and going and scanning the thing, and maybe not a construction worker, but like someone who owns this equipment, and scanning it and being like, oh, okay, it's time to get a new tread on this, and then calling up the company and ordering one, or maybe even ordering it from within the app if the manufacturer provided that. So that would be a very easy application for LiDAR. Cool. Well, hey, those were some great questions. Just want to thank everybody for coming. Had a great time putting this together and talking to you all. And thanks especially for your quick no, Dan. Anyway, hope you all have a great weekend, and thanks for showing up.